In our lesson today, we're going to investigate properties of logarithms, and there are three specific properties that we're going to investigate: when there's a product, when there's a quotient, and when we have a power. Let's start with the product rule. If we have a logarithm of some base b, and it's the product of two numbers a times c, you can rewrite that as the product of log base b of a plus log base b of c. Okay, they're going to have the same base b, and then this time, instead of multiplying them like this, log base b of a plus log base b of c. If there's a quotient, for example, log base b, and it's a divided by c, well, this time I can rewrite this as log base b of a minus log base b of c. Okay, and then same thing if we have a power, there's a different rule. If I have log base b and I have some number c raised to a power of a, then I can rewrite this as a times log base b of c. All right, so the a is going to come down as a multiplier times log base b of c. These are the three main rules that we're going to be using in order to rewrite as single logarithms. So in my first example, it says to write as a single logarithm, I have the logarithm of 7 plus the logarithm of 5. And when it just says logarithm, it's important to remember that this is a base of 10. So these do have the same base, okay? And if it's a sum like this, well, going back up to my rules from above, I know that I could rewrite that as a product. Okay, so this is going to turn into something that would look like log of base 10 of 7 times 5. But again, I can just rewrite that as my log base 10 of 35. Okay? In example 2, again, it says to rewrite as a single log. I have 5 times the log of 3 plus the log of 4. And again, these are both base 10. And the first thing I'm going to do, I'm going to rewrite this first part here using the power rule. Okay, I know that if I've got a times log base b of c, that I could rewrite that as log, and again, this is base 10 of 3 to the 5th power, okay, plus log of 4. And now, since this is an addition, okay, since it's an addition, I can use my product rule. I can rewrite this as a sum, or excuse me, it's already a sum. I can rewrite this as a product. So what I'm going to do now, I'm going to write this as log, and that was log base 10, log base 10 of 3 to the 5th power times 4. Okay, since these were broken up as a sum, I can rewrite it in one term as a product. And now I can evaluate this and figure out how much this is going to be. Well, again, it's still going to be log base 10. 3 to the 5th power, 3 times 3 times 3 times 3 times 3 is equal to 243 times 4. And so when I multiply those, this is going to be the same thing as log base 10 of 972. Okay, so using a couple of my rules, first I rewrote this as a product. Excuse me, this was a product. I used the product rule to write, or excuse me, this was a power. I used the power rule to write this 5 log 3 as log base 10 of 3 to the 5th. And then because this was a sum, I could use the product rule here, 3 to the 5th times 4, and that comes all the way out to be log base 10 of 972. In the next example, we're asked if a is equal to 10 and log base 5 of b is equal to 9, then what is log base 5 of a times b? And in order to help me with this, I'm going to use a few of my properties. Noticing right here that this is a product, I'm going to break this up. I'm going to rewrite this as log base 5 of A plus log base 5 of b. Okay, and this is already helpful because I know here they told me that log base 5 of b is equal to 9. So all of this right here is just equal to 9. Okay, I was also told here that a is equal to 10. So I'm going to rewrite this entire thing. This is going to be log base 5 of 10 plus, they told me again, log base 5 of b is equal to 9. So this is all just plus 9. Okay? And now I'm going to see if I can evaluate what this is going to be equal to. And again, I'm going to use my log rules from last class. I can rewrite this as log of 10 over log of 5. And again, I'm going to add 9 to that at the end. And if I use my calculator here, if I do log of 10 divided by log of 5, I get this decimal here. Okay, so I'm going to write that decimal out. Okay, so I have 1 and 430676558. And if I add 9 to that, well then this is going to equal 10 and 430676558. In the next example, it says if log of m is equal to 5 and log of n is equal to 3, determine log of m to the third power times n to the second power. And I'm going to notice here that I have a product inside, so I'm going to use my product rule to rewrite this. Log of m to the third times n to the second. I'm going to rewrite that as log of m to the third power plus log of n to the second power. And now what I'm going to do, I notice that I have some powers in each of these, so I'm going to use my power rule to rewrite each one of those. So the first one, log of m to the third, is going to be equal to 3 times log of m, plus the next one, log of n to the second power, is going to be equal to 2 times log of n. And now this is easy for me to evaluate since I know log of m equals 5. This is equal to 3 times 5 plus, since I know log of n is equal to 3, this is equal to 2 times 3. And now this becomes an easy problem for me to do. 3 times 5 is 15, plus 2 times 3 is 6, and so I get a final answer of 21. In example 5, I'm asked to solve for y, and I know that log base 2 of 5 plus log base 2 of 8 is equal to log base 2 of y. And in order to help me figure out what the value of y is, I notice here that I have a sum, and they have the same base of 2, so this is actually my product rule, and I'm going to rewrite this as a logarithm with a product. This is going to turn into log base 2 of 5 times 8, which is going to be equal to log base 2 of y. Okay, and now evaluating here, 5 times 8 is 40. So log base 2 of 40 equals log base 2 of y. And since these two values have to be equal to each other, I have log base 2 of 40, log base 2 of y. That must mean that this value of y is 40. Y is equal to 40. In example 6, I know that if they tell me that if 3 times the log of xy is equal to 3, they want me to determine what the value of xy is going to be. Okay, so I'm going to rewrite this. 3 times the log of xy is equal to 3. And I'm trying to figure out what's the value of this x times y. Okay, well the first thing that I'm going to do, I'm going to divide both of these numbers by 3. And this is going to be useful for me since 3 divided by 3 is 1. That leaves me with log of xy is equal to 1. Okay, and remember that this is a log base 10. Log base 10 of xy is equal to 1. Well, if I take this logarithm form and write it in exponential form, that tells me that 10 to the first power is equal to the value of xy. From last time, we can rewrite this logarithmic example as an exponent. 10 to the power of 1 is equal to this x times y. Okay? So, in order to figure out the value of x times y, I just need to evaluate what 10 to the first power is. Well, 10 to the first power is 1, so that means that x times y must have a value of 10. Example 7 is very similar to example 6. It says if negative 2 times the log of a over b is equal to negative 4, determine the value of a over b. So I'm going to start by rewriting it. Negative 2 times the log of a over b equals negative 4. And the first thing I'm going to do, I'm going to divide each side by that negative 2. Since negative 2 divided by itself is 1, that leaves me with log of a over b equal to negative 4 divided by negative 2 is 2. Okay, so now again, this is log base 10. And I can take this logarithmic form and rewrite it in exponential form. So I know that I've got a base, my base is 10, so I'm going to have 10 to the second power equal to a over b. Okay, 10 squared equals a over b is the same as log base 10 of a over b equal to 2. These are equivalent to each other. So to get the value of a over b, all I have to do is figure out the value of 10 to the second power. And I know that 10 to the second power is 100. So 100 is equal to a over b.